by the time that we are completed with the notes today, you should have a better understanding of how to name binary molecular compounds. Now, it's going to start to get a little bit more challenging because this brings in to play a second system of naming. The problem that a lot of people have had that I've seen throughout the years is they mix up the two different methods. So they want to use the molecular way to name ionic things and vice versa, using the ionic way to name molecular compounds. So it's important that you understand how to take into the different directions. Why do we go into the molecular direction? Why do we go into the ionic direction? That leads us off to the first part here on the slide. Molecular compounds are composed of individual covalently bonded units called molecules. Now, when we talked about covalent bonding, we said that we name anything that is covalently bonded a molecule. Okay? Molecules covalent bonding are dealing with what types of elements? What types of elements? Nonmetals, okay? So when we have nonmetals, we are going to use the molecular way to name these. So, how do we differentiate between the two? Okay, how do we differentiate? The first question you should ask yourself is, am I dealing with a metal, a nonmetal? Am I dealing with polyatomics? Okay, metal and a nonmetal and polyatomics are all ionic bonding, meaning you would use the ionic way to name things. If I'm dealing with two nonmetals, I am going to use the binary molecular way to name things. Now, we use two different systems when we use binary molecules. The first one we're going to talk about is the newer stock system for naming molecules. The newer stock system for naming molecules. We will discuss that later on in this unit. We have to have oxidation numbers and an understanding of oxidation numbers in order to do this stock system of naming binary molecular compounds. So I believe in a couple of days we are going to be dealing with oxidation numbers. So about mid to the end of the week we'll be dealing with this system of naming. Today we are going to discuss the older system of naming, which uses prefixes, and I just simply call it the prefix system. When dealing with the prefix system, we have rules that we follow, and the very first one is right here. The least electronegative element is given first. And when naming these, we just use the actual name of the element. We use a prefix if that element contributes more than one atom. And I'll show you this here in a little bit when we're working examples. If it only has one atom, we do not use a prefix. Okay? We do not use a prefix if it's only one atom. The second element, we use a combination to name it. We start with a prefix indicating the number of atoms contributed by the element. The second part is the root of the name of the second element followed by an IDE ending. Followed with an IDE ending. So with a very few exceptions, if something ends in IDE, it indicates that you will most likely have a compound that has two elements. Now, I said that there are some exceptions, okay? And there are, but most of the time, if you have an IDE, ending tells you that you have two elements. Now, we've done this IDE ending with the base. So we've done B and C before. Remember, we transferred chlorine into chloride, right? Bromine, bromide. Iodine, iodide. Oxygen, oxide. We've done that IDE ending. But the new part here is adding the prefix. Okay? Adding the prefix. Now, you might be asking yourself, okay, what are these prefixes? We'll go over those here in a bit. We'll go over these here in a bit, but this last little rule here is just saying that, hey, if there is an O or an A at the end of the prefix, it's usually dropped if the word begins with another vowel, meaning oxide. Okay? Instead of pentaoxide, it's just pentoxide. So they don't have an A-O, P-E-N-T-A-O-X-I-D-E. So usually the A or the O at the end of the prefix is dropped if we're dealing with another vowel. It doesn't say anything about an I, does it? Make note of that. Only A and O. Doesn't say anything about an I. Now we have 10 prefixes that we will be using, and I have them listed up here. So get these prefixes in your notes, and then we'll discuss how we use them. Okay, mono is 1. Di is a prefix for 2. Tri is 3. Tetra is 4. Penta is 5. Hexa is 6. Hepta is 7. Octa is 8. Nona is 9. Deca is 10. So those are all of your prefixes that we will be using when we will be naming binary molecular compounds. And we're going to go through and work a couple of examples here. The first one we are going to start with is N2O3. Now, if we go back and we follow our rules, we know that the nitrogen is the least electronegative one because it's first. So, with the first one, it tells us just to simply write the word, which is nitrogen. Now, do we have more than one nitrogen atoms? Yes, we have how many? We have 2. So we need a prefix. If you only have 1, you don't need a prefix. You never put mono on the first word. Okay? We do not put mono on the first word. This one we have more than 1, don't we? How many do we say we had? 2. So what's the prefix for 2? Di. So this is dinitrogen. The second one, we have a prefix, we have a root, and we have an IDE ending. So what is my root and IDE ending for this? Oxide. We've dealt with oxide before. Oxide. How many oxides do we have? 3. So the correct name, ladies and gentlemen, for N2O3 is dinitrogen trioxide. Dinitrogen trioxide. Here is the second one. PCl3. PCl3. What is P? What's P? Phosphorus. Oops, not phosphorus. Phosphorus. Now, on phosphorus here, ladies and gentlemen, how many do we have? We only have 1. And we do not, once again, we do not put mono on the first word. So this is just phosphorus. What is our second word? Base with the IDE ending? Chloride. How many chlorides? 3. So, phosphorus trichloride. Now, once again, just a little review. What type of elements are we dealing with here? 2 nonmetals, correct? 2 nonmetals. Our next example, SCl2, or excuse me, Cl5, SCl5, go ahead, name it, then I'll write my name up here. Well, I won't write my name, I'll write the name for the chemical, for that formula. So you try to name it. And then I'm going to name it. As I come up, sulfur is the first one. There's only one of it, so I do not put a mono. 5 is penta. Pentachloride. Sulfur pentachloride. Now go ahead, just like I did that one, go ahead and work. Go ahead and work this example, and then I'll do it on the board. Now, ladies and gentlemen, if it's anything like previous years, my classes, I would say 90% of you miss this one. Okay? Not Kane? Huh? You didn't write her down. You could do it. You know how to do it. But I'm going to say 90% of you miss this one because of the rub here. Here's the rub. Are we dealing with 2 nonmetals? No. We have a metal and a nonmetal. This is ionic bonding. So, if you name this tin tetraiodide, you're wrong because you named it using prefixes. That is molecular. Okay, I put that on there for a reason to get you thinking, all right, we have to look, do I have 2 nonmetals or do I have a metal and a nonmetal? You know how to name this one. We've already dealt with ionic ones. This would be tin parenthesis 4, tin 4 because I need a Roman numeral, tin 4 iodide. So this is the way you named last week's stuff, with an ion sheet. Now, how did I get 4? How did I know it was tin 4 and not tin 2? I need to look at the iodine, right? Iodine is a -1 charge because it's a halogen, and I have 4 of them. So I need 4 positive charges to counteract the negative, to balance out the negative charge. Okay? So that's the rub right there, folks. That's the big deal. That's the thing. I need to go through and I need to ask myself every time I'm doing these, do I have 2 nonmetals? Or do I have a metal and a nonmetal or a polyatomic? Anytime we're dealing with polyatomics, it's going to be ionic because literally they are called polyatomic ions. Okay?